propagating errors. When you're writing a function whose implementation calls something that might fail, instead of handling the error within this function, you can return the error to the calling code so that it can decide what to do. This is known as propagating the error and gives more control to the calling function where there might be more information or logic that dictates how the error should be handled than what you have available in the context of your code. So what they're saying here is that the example is like when you're writing a library and other people are using the stuff. Other people are using the stuff that you wrote. You may not have the entire context of how they want to handle this error. And since you don't know how they would like to handle this error, the best thing that you can do is propagate the error up, as in return the error that you had to them and let them handle it. Let them deal with the error in whatever way they see fit. Here's an example. Enlisting 9-6 shows a function that reads a username from a file. If the file doesn't exist or can't be read, this function will return those errors to the code that called this function. So as you can see, we do a few imports: file, IO, read, file. We have a function name. We're returning a result that has the OK variant as a string, and we have our error. We have to open the file, and then post opening the file, we have to read from the file. So that's two different actions. So the first action is we open the file, and then we check to see if that was OK. If that is OK, this F is file. If that was not OK, we immediately return the error, which satisfies this result enum. Right here, we wrap it in the error result : error. If we do have the file, we continue down the function, right? And then we create a variable s, and we're trying to read from the file now. So this reading is the second action. This reading can go successfully, and we can have an OK, or it can have an error. However, at this point in time, that's all we want to really return. If it's OK, return the OK enum. If it's an error, return the error enum. And this function, in terms of what it needed to do, is done. And I can write that out because this is a hello text file and I just have to put stuff in it. So yeah, we can test this out. Oh, we can at least write out the function and then call it, seemingly. Do they ever call it? I don't think they call it. That's silly. Okay, so let's write this out. Use standard library, IO. Use standard library, IO read. Use standard library, file system, file. Right? I'm creating a function called read username from file. It takes no parameters, meh, but it returns a result, right? Result. I'm going to say it's a string or it's IO error. The reason why it's an IO error is because we're doing two IO operations and they both return IO error, so that just makes it easy for us. I think we could have probably returned a different type of error if we wanted to. I'm not explicitly sure on that, but there has to be different types of errors. And in here we say let f equal file open infamous hello.txt file text. We do our first action. Well, the first action was opening, and then we're checking to see if that was successful. Match f if it was OK, return the file. If there was an error, explicitly return right here the error. And now we continue onward. let mutable s equals string new. We do the math to check to see if we can read from this. They did read to string. Read to string. We pass in our pointer to our mutable string. And if that is okay, sure. Return okay within s. Oh, I think the reason why this is underscore is because the value of okay, at least the one that's passed back in from here, doesn't really matter because this was a mutable reference. So s exists here. We passed in a reference here, but s is still within, it didn't borrow. We just passed in a reference. It doesn't take ownership. So we can still access s, and this is where we should be accessing s. We just changed the value of it within there. And then error e, we pass back the error type, and that is the end of this function. And now we should try to call it. So let's erase this. If we wanted to call it, we can say let, I don't know, they said username, right? Username equal read username from file. And you can see our username takes that type of a result. And then we can probably do match username and then figure out what we want to do. If it is a okay, I guess name, print line, ooh, print line, username, name, and if it's an error, we could panic, but yeah, I guess just panic. Panic. The debug information. And that's going to be, I guess it's going to be returned, so I guess I could leave it like that. Currently, we do not have a file called hello.txt, so this should fail. And as you can see, we got our panic, which is right here. We have our error, and we have the debug information, right? But let's say we put information within hello.txt. We create a file called hello.txt, so let's touch hello.txt, and can I use micro here? Huh. marcus. Control save. Control exit. I'm not sure if that worked. That cut the line. Save changes? No. That went really dark. I've never used micro. It's another editor that I use for my terminal editor. I've never used it within this thing. I don't like how that syntax, the darkness of it. But let's just verify that we have something in that file. So cat hello.txt, it has my name, Marcus, no new lines. A little awkward, but okay. So now if we run this program, it returned Marcus. Cool, right? Moving on. This function can be written in a much shorter way, but we're going to start by doing a lot of it manually in order to explore error handling. At the end, we'll show you the shorter way. Let's start at the return type of the function first. Result, string, error. This means the function is returning a value of type result T and E, where the generic parameter T has been filled in with the concrete type string, and the generic type E has been filled in with the concrete type IO error. If this function succeeds without any problems, the code that calls this function will receive an OK value that holds a string. The username of this function reads from the file. If the function encounters any problems, the code that calls this function will receive an error value that holds an instant of IO error that contains more information about what the problems were. We choose IO error as the return type of this function because that happens to be the type of error value returned from both the operations we're calling in the function's body that might fail, the file open and the read to string method. So yeah, I was right about that. You can change the error type. They chose that one explicitly because of these reasoning. That's the type of error that these two things return. The body of the function starts by calling the file open function. Then we handle the result value returned with a mat similar to the mat in listing 9-4. Only instead of calling panic in the error case, we return early from this function and pass the error value from file open back to the calling code as the function's error value. If, let's stop right there for a second. So what they're saying in this chunk is what we have right here, right? This is similar to what we wrote in 9-4. We were checking to see if the file opened properly. Before we were just panicking here. Now, given that we want to return or propagate the error up, we're explicitly returning this error instead of panicking. That's all they said here. And if the file open succeeds, we store the file handle in the variable f and continue. If it succeeds, file gets stored here, and then we continue on with the program. Then we create a new string in variable s and call the read to string method on the file handle in f to read the contents of the file into s. What they said in that sentence is we created a new string that is mutable, and we want to use this method called file to string that's on the file handler to read the contents of the file that we just opened and copy them over to s, this string that we just created. The read to string method also returns a result because it might fail, even though file open succeeded. So we need another match to handle the result. If read to string succeeds, then our function has succeeded and we return the username from the file that's now in s wrapped in an OK. If read to string fails, we return the error value in the same way that we return the error value in the match that handled the return value of file open. However, we don't need to explicitly say return because this is the last expression in the function. So what we're saying here is that if there's an error, we do this error thing. If it's okay, if there's no error, we do this. And we want to return these because, we want to return result, or a type of result enum. But we don't have to explicitly use the return because this is the last expression in the function, thus it by default gets returned. The code that calls this code will then handle getting either an OK value that contains a username or an error value that contains an IO error, which is what I did down here. I am calling this function, which we created up there, and then I am dealing with the two cases. We don't know what the calling code will do with those values. If the calling code gets an error value, it could call panic and crash the program, use a default username, or look up some username from somewhere other than a file, for example. We don't have enough information on what the calling code is actually trying to do. So we propagate all the success or error information upward for it to handle appropriately. Summary there, they don't know what the calling code is trying to do. They don't know the business logic. They don't know anything about that, at least not in the context of this function here. So the best thing they can do is pass back or propagate the error and success value And then the calling code can choose what they want to do with that information. This pattern of propagating errors is so common in Rust that Rust provides the question mark operator to make this easier. Next section. A shortcut for propagating errors, the question mark operator. Listing 9-7 shows an implementation of read user from file that has the same functionality as it had in listing 9-6, but this implementation uses the question mark operator. All right, see what they did down here? They put a question mark there. Okay. And then put a question mark here. And then they returned okay. Understood. So let's rewrite this. Make this a little bit smaller. Here we go. So this no longer needed. They took out this match. Put a question mark here. And then a semicolon. I can adhere to the space. Then they took out that match and just did an f dot read to string, pass in the mutable s, question mark, colon, and then OKS. Hold on. Oh, they have to let f be mutable. S is mutable, F is mutable. I don't think F wasn't mutable before. Oh, that was a change. Let's go back to that. Yeah, it was not mutable here, and this was fine. But down here, it is not. Okay, that's something to note. And if we run this, we should get username Marcus. Output is still the same. Cool. And the inputs are the same. Got it. The question mark placed after a result value is defined to work in almost the same way as the match expressions we defined to handle the result values in listing 9.6. If the value of the result is an OK, the value inside the OK will get returned from this expression, and the program will continue. If the value is an error, the error will be returned from the whole function as if we had used the return keyword. So the error value gets propagated to the calling code. So it was exactly what we were doing before. So what they're saying here is the question mark does this verbatim. If it is okay, it returns okay and continues with the code. And if it is not okay, we have an error. It acts like an explicit return and returns the error, which is fine in both cases. We didn't have an explicit error here because this was at the end of the function, thus it always returned. But yeah, that's completely fine. Cool. There is a difference between what the match expression from listing 9.6 and the question mark operator do. Error values that have the question mark operator called on them go through the from function, defined in the from trait in the standard library, which is used to convert errors from one type into another. When the question mark operator calls the from function, the error type received is converted into the error type defined in the return type of the current function. This is useful when a function returns one error type to represent all the ways a function might fail, even if parts might fail for many different reasons. As long as each error type implements the from function to define how to convert itself to the returned error type, the question mark operator takes care of the conversion automatically. That's interesting. So what they're saying here is the difference between match and the question mark operator is that the question mark operator calls or goes through this from function, which is a from trait. And what that does is it converts the error type it is receiving, and it takes the error type it is receiving and it converts it to the error type listed in the function signature. In our case, it doesn't matter because both of these return io.error. However, they return something else. Seemingly, what this would do is convert whatever that error was into an io error and then return, just to satisfy the signature. I guess that adds for more flexibility. At the same time, it's kind of questionable, but it adds some more flexibility, definitely. In the context of listing 9.7, the question mark at the end of the file open call will return the value inside OK to the variable f. If an error occurs, the question mark operator will return early out of that whole function and give any error value to the calling code. The same thing applies to the question mark at the end of the read to string call. The question mark operator eliminates a lot of the boilerplate and makes this function's implementation simpler. We can even shorten this code further by chaining method calls immediately after the question mark as shown in listing 9-8. So they're saying this could just be one line for the most part. We can move that up or we can move the other thing down. Oh, we can move this up, cut, enter, paste. This thing can be changed. Don't need to define file. We can do file open, question mark, dot, and then do the read to string, pass in the mutable, s, no, s is fine, question mark, semicolon, and then return the OK for s. And this should do the same thing. These 3 lines should do the same thing that we had many lines to do earlier. And it runs. So this is chaining. We have the first call, we do a dot, and then we chain the next call onto it. I did not mean to do whatever I just did. I don't know what I just did. See if it still runs. Still runs. I did nothing. Good. We've moved the creation of the new string in S to the beginning of the function. That part hasn't changed. Instead of creating a variable f, we've chained the call to read to string directly onto the result of the file open hello text. We still have the question mark at the end of read to string call, and we still return an OK value containing the username in S when both file open and read to string succeed rather than returning errors. The functionality is again the same as in listing 9.6 and in listing 9.7. This is just a different, more ergonomic way to write it. Okay? Speaking of different ways to write this function, listing 9-9 shows there's a way to make it even shorter. And wow. So it looks like we didn't have to open this file at all. It looks like, based on what they have here in 9-9, we can look at it. There's no file open. They just go straight from file system read string and pass in the name of the file. That was probably specified in the documentation, but it looks like this both opens and reads. Okay. So get rid of this. And get rid of this. Do standard library file system. Start from file system. And in file system, looks like they have a we'll read the strings already there. And they have the path. This takes the path. And the path to the file is hello. Oh, yeah, that has to be changed. The path to the file is hello text. And there is no okay, this returns a result itself. We have no need to declare a variable. We have no need to make this a function actually, because it's just one line and we're calling another function. And that's seemingly it. Let's run this again. And that works. So this does seemingly what we were doing before explicitly. Okay. Reading a file into a string is a fairly common operation. So Rust provides the convenient read to string, our file system read to string, function that opens the file, creates a new string, reads the content of the file, puts the content into that string, and returns it. Of course, using file system read to string doesn't give us the opportunity to explain all the error handling, so we did it the long way first. Okay. Just for the sake of argument, for the sake of doing this example, they made us write out seemingly what read to string does under the hood, and then showed us that we could just do it with a convenient call that they have, file system read to string, which does everything that we wrote. Understood? The question mark operator can only be used in functions that return result. That's good to know. The question mark operator can only be used in functions that have a return type of result, because it is defined to work in the same way as the match expression we defined in listing 9.6. The part of the match that requires a return type of result is return error, this thing. So the return type of the function must be result to be compatible with this return. Okay, so what they're saying here is that if you're going to use a question mark, the only thing you can use a question mark on are things, functions, I guess methods too, that return a result type. And this is explicitly stated because the operation that the question mark operator does returns an explicit error, the result error enum type. So for compatibility reasons, this is mandatory. Let's look at what happens if we use a question mark operator in the main function, which you recall has a return type of nothing. I see why this is an example. Understood. I'll write it out. Get rid of that. Get rid of this. File system. File. Get rid of the IO. Alright, so the reason why this is an example, this is showing us what happens when we have a function call that has no return type, or has a return type that is other than results, and we want to see what happens, what error it gives us. So main function doesn't return anything, so this should fail. File, open, path, hello.text, and we get a question mark and a semicolon, and come here and let it blow up. And it says you cannot use the question mark operator in a function that returns this, nothing. And it gives us help, the trait, standard library. Is this supposed to be ops or oops? Call it oops. It looks like ops though. Try is not implemented for blah blah blah. Note required by from error. This is probably the from error that they were talking about earlier with the question mark and how it converts errors from one to another. Okay. And here I think they're a little bit more explicit. The question mark operator can only be used in a function that returns result or option. So you can return option or another type that implements the standard ops try. Duly noted. This error points out that we're only allowed to use the question mark operator in a function that returns result or option. I mean, they say option here. Or anything that implements this. Ops, oops, try. When you're writing code in a function that doesn't return result and you want to use question mark when you call other functions that return result, you have two choices to fix this problem. One technique is to change the return type of your function to be result, if you have no restrictions preventing that. The other technique is to use a match or one of the result methods to handle the result in whatever way is appropriate. The main function is special, and there are restrictions on what its return type must be. One valid return type for the main is this thing. And conveniently, another valid return type is result t as shown here. Or, sorry, result enum as is shown here. So this is like a peek underneath the hood. So what they were saying here is that if you have a function that does not return a result and you still want to use the question mark operator, you have two options. The first option is modify your function so that it returns a result and you're good. The second option is to use a match or one of the result methods to deal with the result in a way that is appropriate. They didn't really give us an example of that here. What they did go on to say is that the main function is special, and there are two valid return types, seemingly. We have this open thing, just brackets right there, and then we have the return type of a result, and this is seemingly okay, given that our main returns a result, and we specify it here. We have a box and something error. This box dyn error type is called a trait object, which we'll talk about in the using trait objects that allow for values of different types section in chapter 17. For now, you can read box dyn error to mean any kind of error. Using question mark in a main function with this return type is allowed. That seems a little like black magic, but they said they're going to explain in chapter 17, so we have some time. Now that we've discussed the details of calling panic or returning result, let's now return to the topic of how to decide which is appropriate to use in which cases. And that will be the end of this video. I hope it was entertaining. I hope it was useful. Hope you learned something. I did. Good luck with your errors. Peace.